do have three back-to-back questions here that I'd like to ask you. So first one is up here. What is the correct condensed structural formula for hexane? What is the correct condensed structural formula for hexane? And so we'll wait. I don't know where the heck is everybody today. Unfortunately, I'm hoping that they're listening. I'm hoping you're listening to this. All right. Because it turns out that students that miss this stuff tend to not do very well at all on the next exam. So, again, model kits are up here. Anybody else that's on Thursday? We have more than 16 people here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 2, 3, 4, 25. We can get some more people locked in here. We only got 14 of you. So let's get an answer in here, please. This is a way that I keep track of attendance, recall. And if you have that finished, you should be having built a model of C4H8 with a double bond that is different from your nearest neighbor. All right, we'll give you about 10 seconds here to get an answer locked in. And we're going to count down. 5, 4, 3, 2, 1. All right, letter C, choice C, looks good. Any questions on the first one? Okay, here comes your second one. This is a line formula. For which substance? This is a line formula for which substance? All right, we'll count down here. 5, 4, 3, 2, 1. And how do we know that this is heptane? What do we count? The points. And which atom is at each point? Carbon. And if we look at the carbon that's right here, how many hydrogens is this carbon atom attached to? 2. How many hydrogens is the carbon at this point attached to? 3. Good. Any questions on that? Okay, and then the last one. The chemical formula of an alkane that has 20 carbons would be, what is the formula of an alkane that has 20 carbons? Let's get your answers locked in here, please. And we'll count down. 5, 4, 3, 2, 1. And how do we know it's choice E? C20, H22. What is the general formula for an alkane?
Multiply by 2 and then add 2.
Right, so the general formula is CN, H2N plus 2 for an alkane. Which means if we have 20 carbons, the number of hydrogens will be 2 times 20, which is 40 plus 2 more gives us 42. Any questions on these? All right, some announcements here before we go on. Just a reminder here that the last day to withdraw from this course and receive a W grade in here is next Tuesday, a week from today, the 18th. If you're concerned about your status in this course, please see me. Do have a couple of extra credit opportunities. These are beyond what is given in your syllabus in terms of doing the practice problems. These here are ones that come from your lab packet. And so each one of these is worth 2 points apiece. If you do number 11 out of the packet, I think I pulled these up here somewhere. Not here. How about here? Here we go. We have a couple labs. One of them is what I call an experiment, which involves a reaction which you're going to be using a raw egg in a shell. And then the second one is one that you'll be using red cabbage indicator, and you're going to be making an acid-base indicator using some red cabbage. In terms of your time commitment, the first one will take 3 days, and that doesn't mean 3 days you're going to be sitting there collecting data for 3 long days. Probably means you're going to take about 5 to 10 minutes a day on each one of these, and then probably the last day maybe about half an hour to 45 minutes to write up your results. So if you were to do this, one of the places you're going to find that information is on D2L. If you go into D2L, you will go, and this is into the lecture course up here, you'll then go to the Dropbox or the assignment submission folders. You're going to find here at the very bottom the different labs. One is the experiment, and this is a place then where you can drop off your assignments once you're all finished with them. And again, they should also be in your packets, numbers 11 and 12. The primary criteria of these is that you're going to turn in both your pre-lab questions and your post-lab questions and submit them as a single document into the Dropbox. And you will need to provide proof of completion. And proof of completion will either involve taking some pictures, like it says, take a selfie of you with your stuff there, or to go through some different parts of the lab where you take some documentation of it. Or, if you prefer not to do selfies or whatever of you with raw eggs, you can then bring in your tangible product at the end. Each one of them you can probably put in a baggie or Ziploc bag or something, bring it in here. I'll check you off that you have actually completed it. And part of the reason why I do that is that don't want you, in these days with phones where you can swap pictures and everything, don't want you just taking the same picture and passing it to 10 different of your friends or whatever. So it's a selfie with you in it actually doing the lab. So any questions on these? Okay, and as always, the maximum amount of extra credit for the semester is 10 points. So if this takes you up over 10, you'll be capped at 10 points for the semester. So any questions? All right, you should have picked up a couple copies of these handouts, or at least one of each of these handouts. These are from today. Anybody that was gone on Thursday of last week, need a copy of the handout from Thursday? Anybody from Thursday? All right, let's get your handouts picked up. Anybody that missed the one from Thursday? Here's the one from Thursday. Anybody else? All right, let's get going here today. We have this structure right here. What we'd like to do is we'd like to write out a name for the structure. By the way, in order to write out the names, you will need this handout right here. You'll need the one that was sitting out here today. It sits at the top with the IUPAC nomenclature of branched alkanes. IUPAC nomenclature of branched alkanes. Now, by the way, the nomenclature that we're looking at here in Chapter 18 is called IUPAC nomenclature. And IUPAC is an acronym which stands for the International Union of Pure and Applied Chemistry. So again, it stands for the International Union of Pure and Applied Chemistry. And these are rules that are provided by IUPAC. You might say, well, what is so significant about IUPAC? Well, what's significant about it is that if we think of, again, what it stands for the International Union of Pure and Applied Chemistry. So this is an international group involved where the rules were developed from people all around the world. And what this means is that the names that we assign are the same regardless of your native language. And there's not many things that are like that in the world. Math would be an example of an international language. It doesn't matter where you're from, everybody speaks the same language when it comes to math. We use the same symbols and everything else. So the same is true in chemistry. We all speak the same language when it comes to the chemistry of organic compounds. Now obviously these rules are based in English, but it is an international convention, so it doesn't matter again whether it's Spanish, French, whatever, your language is the same when it comes to IUPAC nomenclature. And we had started with these rules in here on last Thursday, and we're just now actually have a copy of them to use. So we're going to start then by naming these molecules following these conventions. And so we'll start with the first one here, and just remind you of these rules we went through the other day. The first thing we're going to do is to identify and name the parent chain. Remember that the parent chain is the longest consecutive chain of carbon atoms in the molecule. So if you look at this one here, and this, by the way, is on the handout from Thursday. This is the first one from Thursday on here. So pull this out if you don't have it out. It's from Thursday. We're looking at the side now that has this structure right at the top. And if we count here, what is the longest consecutive chain of carbon atoms in this molecule? It would be 7. So if we count through here, we have a total of 7 carbon atoms. And so if we were to name this chain with 7 carbon atoms, what is the name of a 7-carbon alkane? Heptane, right. So then our next step on here is to identify and name all of the branches off the parent chain as alkyl groups. An alkyl group is an alkane, which we talked about before. And then we say that the names of the alkyl groups precede the name of the parent chain. So coming back here, how many branches are there off the parent chain? There are 2. This one here and this one here. Now if we look at this first one here, how many carbon atoms are in this branch? 1. And in this branch there are 2. What do we call a 1-carbon branch? Methyl. And a 2-carbon branch would be ethyl. So this is methyl, this is ethyl. From here then, what we're going to do is we're going to locate and assign a number to the position of each branch off the parent chain. And if we have a single branch off the parent chain, we'll count in the direction that gives us the lowest number. This isn't a single branch, we have multiple branches. So when we have multiple branches, we're going to count in the direction that gives us the lowest number for any branch off of the parent. So if we count from left to right, we come up with 1, 2, and in reverse we come up with 1, 2, 3. So which direction should we count? Left to right or right to left? Do we want to go this way or do we want to go this way? We want to go this first way because we go from left to right. This is off of carbon atom number 2. So if we count then, we establish that convention where we count 1, 2, 3, 4, 5, 6, 7. Once we've established that direction, then the methyl group is attached to carbon atom number 2 in the chain, and the ethyl group is attached to carbon atom number 5 in the chain. So going further with this, it says that if we have these multiple branches, first of all we count in the direction that gives us the lowest number. Now are these branches of the same type or are these branches of different types? These are different types. So now if we have branches of different types, what we say is the alkyl groups are named in alphabetical order, the number indicating the position of each alkyl group off of the parent chain. So again, this one is called methyl. This one is ethyl. So which one comes first alphabetically? Ethyl does. So we're going to put its name first. Ethyl comes before methyl. And then what we're going to do, according to the name, is this. We are going to put the number in front of the particular alkyl group. So we tell where the ethyl group is located. Remember, the ethyl group is located at carbon number 5, and the methyl group is at carbon atom number 2. So we put it in like this. And so the number precedes the name of the alkyl group. Numbers and letters are always separated with a hyphen. So you have numbers and letters always separated by a hyphen. And if we have numbers that are adjacent to each other, numbers are separated with a comma. So we say that the name of this one here is 5-ethyl-2-methylheptane. 5-ethyl-2-methylheptane. And again, this is written as one word, and this one word has no spaces in it. So any questions on this particular one? Okay, let's go down to the next one. Longest consecutive chain of carbon atoms in this one. Now be careful on this one. Now if you're determining the longest consecutive chain, you should be able to trace through them without lifting your finger. So if you're to trace through these, what is the longest consecutive chain of carbon atoms in this molecule?
7.
It is 7, not 6. And where do we get 7 from? Well, we start right here. We count 1, 2, 3, 4, 5, 6, 7. So part of the reason for this, remember that a feature of single bonds is that single bonds are always rotating. So if we have single bonds in molecules, they're always spinning around like this here. And sometimes they might be spun around so that they are pointing down, kind of like this is here. And other times they might be sitting out here, so it looks maybe a little bit more linear in there. So because they're always spinning around, we do want to make sure that we trace through the entire path. And so this one here, if we were to determine that parent chain, it looks like this. Right here, there's our 7 consecutive carbon atoms. With 7 consecutive carbon atoms now, this parent chain is called heptane. Now that we have heptane, how many branches are there off of the parent chain?
3.
There's 3. We have 1, 2, 3. And so anything that's not a part of the parent chain is considered to be a branch off the parent chain. Well, now that we have 3 different branches off of the parent chain, we then ask ourselves how many carbon atoms are in each branch.
1.
There's 1. There's 1 in this one, 1 in this one, 1 in this one. So what do we call a 1 carbon branch?
Methyl.
A methyl group. And if we have multiple branches off the parent chain, so here we now have branches of the same type, we indicate the number of that type using the Greek prefixes di, tri, tetra, etc. in front of the name of the alkyl group. So in this case, which prefix are we going to want to use?
Tri.
Tri. So we're going to call it trimethylheptane. Trimethylheptane. And again, this should all be one word. So I'm going to slide it over there so it looks like it's one word, trimethylheptane. Now we want to count in the direction that gives us the lowest number off the parent. So if we count from left to right, we come up with 1, 2, 3. If we count from right to left, we come up with 1, 2. So the direction we want to go in this one is?
Right to left.
Right to left. Because if we go from right to left, this is now branched off to carbon atom number 2. So we have this attached to carbon atom number 2. This is attached to number 4. And this one now would be attached to number 5. Remember, once we establish that direction, we have to count that same direction for all of them in here. So we have 1, 2, 3, 4, 5. And then we put it in there as 2, what is this now? 2, 4, 5? How do we write in the 2, 4, 5? With commas, exactly. So we call this 2, 4, 5 trimethylheptane. 2, 4, 5 trimethylheptane. Any questions on this particular one? Okay, let's go down to the next ones to practice. Oh, they're at the bottom. There we go, sorry. Now these, we are given names, and now that we're given names, we would like to write out a structure for these. So the first thing we should do, we're still going to apply the rules in the same order. We always start by looking at what the parent chain is. So now we've named that parent chain, but the parent chain is given in this case, so working the other direction, we then look at this portion of the name right here, and this portion of the name tells us how many carbon atoms are in that parent chain, and how many would there be? 6. So we put in 1, 2, 3, 4, 5, 6 carbon atoms. So that takes care of the hexane. Then we look at the branches off the parent chain. How many branches are there off of the parent chain? There's 3 of them. One branch here is attached to carbon atom number 4, and this branch has how many carbon atoms? 2. And how many branches are designated here?
2.
2 of them. And each branch is going to have how many carbon atoms?
1.
1. Because the prefix meth means 1. And these branches are going to be off of carbon atoms number 2 and 3. So let's see how this goes. We're going to have one branch off the parent, off of carbon atom number 4. This is going to have 2 carbon atoms, again off of carbon atom number 4. And these branches will each have 1 carbon atom, and they are going to be branched respectively off of carbon atoms 2 and 3. Now, does the position of these matter, whether we write them top or bottom? And why doesn't it matter?
They rotate.
Remember, single bonds, they rotate. Plus, if we're showing it this way in the bottom, all I need to do is flip it over and we are showing it on the top. So it doesn't matter whether we show them on top or bottom. Usually, though, it's easiest or best if you stagger them like I do here, and that way your carbons and hydrogens aren't overlapping each other. Then we start writing in hydrogens. This one up here would have 3. This one here on the end would have 3. Now look carefully. How many is this one here going to have?
1.
Just 1. It's going to have 1 because it's already bonded to how many carbons? 3 of them. So we put in 1 hydrogen here. How many hydrogens on this carbon? 1 here. How many on this one? 1. How many on this one? 2. And on the end one we'd have 3. Then coming down here, this one's going to have how many? 3. This one here would have how many? 2. And this one on the end would have 3. So now that we have this, one of the things you can do is check to make sure that you have the correct number of hydrogens, and we can do that by counting the number of carbon atoms. If we count the number of carbon atoms in here, let's do this now. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 carbon atoms. How many hydrogens should be in here? 22. There should be 22 in there because remember that the number of hydrogens is 2n plus 2. So 2 times 10 is 20, plus 2 more gives us 22. Let's see if we're right. We have 3 here. Plus 6 makes, or plus 3 makes 6. There's 7, 8, 9. This makes 11. That makes 14. Plus 3 more makes 17. Plus 2 makes 19. Plus 3 more gives us 22. And so this then is a way that you can confirm you've placed the correct number of hydrogens in the molecule. Any questions on this one here? All right, go ahead and do the last one here, please. I'll give you. Okay, tell me what's going to go on carbon atom number 3. Ethyl, which is how many carbons? 2. And what's going to go on carbon atom number 4? Which is how many carbons?
4.
3 carbons. And so on the end we have CH3, CH2, CH2. This will be a CH3, this will be a CH2. CH3, CH2, CH, CH, CH2, 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 CH3 here on the end. Now, what you should be able to do is to count carbon atoms. You can also count them based on their names. F means 2, Cop means 3, and Oct means 8. So 2 plus 3 plus 8 gives us 13, which means that the number of hydrogens should be 28. Because 2 times 13 gives us 26, plus 2 more gives us 28. So we count quickly here. We have 3, 5, 7. That makes 10, 12, 13, 14, 16, 18, 20, 23, 25, 28 all together in here. So any questions on how we do alkanes? Any questions on alkanes? All right. Let's see what's next. So you recall that Thursday we started with saturated hydrocarbons. Next we're going to look at unsaturated hydrocarbons. Unsaturated hydrocarbons. And let's just review what these would be. If they're hydrocarbon, that means they contain which elements? Hydrogen and carbon. Don't you like when it's easy like this? It's kind of fun, right? All right. Then if it's unsaturated, what is it they're not saturated with? Hydrogen. And they're not saturated with hydrogen because they have either a carbon-to-carbon double bond or carbon-to-carbon triple bond. So again, these are unsaturated hydrocarbons. They'll have either a carbon-to-carbon double bond or a carbon-to-carbon triple bond. The two categories we are going to look at in here are called alkenes and alkynes. I know we're very creative on the names here. So we say that an alkene, these here, have a carbon-to-carbon double bond. And the alkynes, these here have a carbon-to-carbon triple bond. Now if you notice the sequence that we went through, we went from alkanes to alkenes to alkynes. Can anybody see a way to keep them straight? A little mnemonic. Alkanes, alkenes, alkynes.
We substitute the fourth letter, it goes farther down the alphabet to more bonds.
Right. If they are alphabetical, so alkanes, alkenes, alkynes are alphabetical, and respectively they are single, double, and triple bonds. So if you remember them in that order, then you can classify them and write their names. Because they have to have a carbon-to-carbon triple bond or a carbon-to-carbon double bond, what is the fewest number of carbons you could have in either one?
2.
You have to have a minimum of 2. So now, I don't know that I have any of these already built. Oh, I do. Here's one that has a carbon-to-carbon triple bond in it. And I don't have a carbon-to-carbon here. I can make one really quick. Here's one that has a carbon-to-carbon double bond present in the molecule. And I've got a stick here somewhere. Just take this one. So we have our carbon-to-carbon double bond, carbon-to-carbon triple bond. It's the way we show them. So now, if we were to try writing names for these and look at their structures, let's start by writing one out for this. We look at it, this is going to be carbon, double bond, carbon. Notice that the carbon on each end has how many hydrogens? 2. So we can write it like this. Now remember that your author shows those terminal hydrogens on the left-hand side by writing them on the far left, but this would be the same as writing it as CH2 double bond CH2. Either one is a correct way to write it. And this would be a condensed structural formula. If we were to show this one here, we could show CH triple bond CH, or how could we write it the other way, do you think? Right, HC triple bond CH. And so either way, again, your author likes to reverse them like this, but you will see them if you read through stuff on the internet. You'll see them written either of these two ways on the left-hand side. Turns out that the left-hand side has been more of a European convention, but we're finding that the American convention is changing and becoming more like this one, but you'll still see quite a bit. That's the way that I was taught, and that's the way that I like to write them here. But either one of them is the same thing. So now in terms of naming these, let's see where your rules are. Here we go. This is the bottom of your handout. This is the IUPAC nomenclature for the alkenes and the alkynes. And to help you out in here, here's something I am doing for you, and this, actually we all do this here, 1020 at enough Ramsey. You're only going to be responsible for the straight chain alkenes and the alkenes and alkynes in Chem 1020. When we say straight chain, that means when we look at the alkenes and alkynes, we're not going to worry about naming those that are branched. Now, while I say that, if you look at Mastering Chemistry, you will find some branched stuff in there. That's because I can't eliminate some of those. But if you look at this worksheet, what you'll find out is that I've not assigned any branched ones here for the alkenes or alkynes. So if you can do the ones that are on this worksheet, this is almost like what you're going to be seeing on your exam in terms of your expectations. Okay, so this is very close to what exam questions would look like. There'll be a few more. You can kind of think of your Socrative app questions as well, but this is very much what your exam is going to look like as far as your problems on there. So with that in mind then, what we're going to do is we're going to count the number of carbon atoms in the molecule, and then we're going to write the name of the alkane that has the same number of carbon atoms. Then what we do is, if it's an alkene, we drop the A-N-E suffix from the alkane name, replace it with an E-N-E suffix. Now if it's an alkyne, we drop off the A-N-E suffix, replace it with a suffix of Y-N-E. So we come back here. Let's name this one here first. How many carbon atoms are there? 2. So if I had a 2-carbon alkane, the name would be ethane. But now because it's an alkene, what do?
Replace it with ene.
Replace it with ene. So we call this one here ethene. And what would we call this one here on the right with the triple bond?
Ethyne.
Ethyne. Ethyne. So again, what we do is we look at the suffix. The suffix tells us whether we're looking at an alkene or an alkyne. Now, as far as the number of hydrogen atoms, here's what the general rule is. I guess before we look at the general rule, look at what happens. If we take this double bond and open it up, how many more hydrogens can we put in here? 2 more. And if we put 2 more in, now we've made an alkane. And so that means that an alkene, because we put a double bond in, a double bond takes away the ability for 2 hydrogens to go in there. That means that the general formula for an alkene is going to be CnH2n. So again, the general formula for an alkene is going to be CnH2n. And if we go to an alkyne, now an alkyne, remember, has a carbon-to-carbon triple bond. If we open this up, we can put in 2 more hydrogens. We open up another one, we can put in 2 more hydrogens. So this now is going to have 4 less hydrogens than an alkane. So it has 4 less hydrogens than an alkane. Its general formula is going to be
CnH2n minus 2.
CnH2n minus 2 as its general formula. And again, that's because each additional bond between carbon atoms takes away the ability for 2 hydrogens to be placed in there. So now let's look at the structures that you built coming in here. You were to build a model of C4H8 coming in. And let's see what some of them are. I'm going to go ahead and just grab one. Who's got one here? Come back here, grab one from Kelsey. Take a look at this one here and see now if anybody has one that is different than this one. And we got one back here. Let's take a look at these 2 now. Any of them that are different from these 2. Okay. So we got another one that's different here. So now I think let's look at these 2 right here. There should be a very clear difference between these 2 here. What is the primary difference between them? We look at what's called the parent chain. Remember that the parent chain is the longest consecutive chain of carbon atoms in the molecule. This parent chain has how many carbons? 4. This parent chain has 3 as the longest. So then we go and start looking at these 2. We ask ourselves, how many is in the parent chain here? 4. And this one here, the parent chain has 4. So then the next thing we start doing is we start looking where the double bond is located. And we start counting. And in this now, we start counting slots. And so this row would be a good example because we have 4 people in this row here. So if we were to count slots, how many slots or spaces are there between 4 people? There's going to be 3 spaces. So if we have 4 carbon atoms, there's going to be 3 slots. Okay? So then we ask ourselves, well, which slot does this double bond come in?
2.
It's in slot number 2 because this would be slot 1. This here would be slot number 2. Well, we come back and look at this one. And we see that this is now located in slot number 2 as well because this is number 1, this is 2. Or in the reverse direction, this is 1 and 2. Well, the difference between these is a difference in what we call cis and trans isomers. And I believe it was about a week ago where we talked about that difference. And cis and trans describes how we orient atoms around the double bond. But before I show that, there's one more isomer out there that's missing. Anybody have that one other isomer that's missing? You got that one there? And let's look at the difference now between these. We now look at where the double bond is located. This one is located in slot number 2. This one here, located in slot number 1. Because if we count, we have 1, 2, 3, or in reverse, 1, 2, 3. Which direction do you suppose we count?
That's right.
We always count the direction that gives us the lowest number, just like before. So these 2 are different from each other because this double bond is in slot number 1. This one here is in slot number 2. So what I want to do here next is I want to show the difference between them. And if we then follow what I said here, and that is the very first statement that says, in this class, we're only going to do the straight chain alkenes and alkynes, which one of these are you not going to be responsible for? Right, you will not be responsible for naming this one here. I'll go ahead and move these back to you, and we'll go ahead and start assigning some names for them. And let's not click your marbles. I'll give you some marble clicking time at the end of the hour today. Thank you, appreciate it. So now, what we're going to do then is to assign some names to these, and we are going to start by looking at this one right here. So we want to assign a name for this one right here. So now we go ahead and write out its structure, and we're going to write a condensed structural formula. And usually the convention when we write them is to show your double bond on your left-hand side. So if we were to write this out, it is going to look like CH2 double bond. Then the next carbon has how many hydrogens? One. And then the next one would have 2, and then the last one would have 3. So now to name this, we go back to our rules, and the rules say here, we're going to locate and assign a number to the slot position of the double or triple bond. And we're going to count in the direction it gives us the lowest number. So in this case here, wherever we are, this slot number is slot number 1. So we write the 1 in front of here. And how many carbon atoms are in that chain?
3.
There's not 3. There are 4 of them. So prefix that stands for 4 is bute. And so we call this 1-butene. 1-butene is its name. Again, the ene suffix in here, and the 1 comes from the fact that this slot is slot number 1. Then if we go ahead and move this to this other position that we had in here, and that one's glued, so I can't do that one. We'll put it here. So now if we want to name this one, that double bond is located where? It's in the slot number 2. So if we see slot number 2, we write it as CH3, CH, double bond, CH, and then on the end, CH3. We would call this one here 2-butene. Now the one that you're not going to be responsible for, let's see if I can get that one here real quick. The one that you're not going to be responsible for, I'm still going to write a name. It looks like this one is glued, so I probably can't do that one either. But let me just go ahead and write it out here. We would put CH3, we'll put a CH3 up above, double bond, CH3. If we were to name this one, we would name the parent chain, which here has how many carbons? How many carbons in that parent chain? There's 3. And because it has a double bond, we would call it propene. And then we'd name this branch off the parent chain, which has 1 carbon. We'd call this one here 2-methylpropene. But again, this is not going to be something that you are responsible for come exam time. You may see something like this on your Master in Chemistry. If you do, do your best with it. But again, come exam time, this is not going to be one that you will be responsible for. What I do want to look at is this one here in a little bit greater detail, because if we look at it in a little bit greater detail, there is one isomer that looks like this, and there's another isomer that if I flip these around, will look like this. And notice now again that these two both have a carbon-to-carbon double bond in slot number 2. The difference is, now if you look at this double bond, these two groups are across from each other. That makes this what we call a trans isomer. And if I were to go ahead and flip these around, that is this one here with this one, we now see where these two carbon atoms are on the same side of the molecule, and that makes this a cis isomer. So to draw them, here's how we draw and distinguish between the two. What we do is we start by drawing out the backbone of a carbon-to-carbon double bond. And that backbone always looks like this. So again, you would show this carbon-to-carbon backbone looking like this. And then once you draw that carbon-to-carbon backbone, then you show where the rest of these atoms go. If you want to show them on the same side, like they are right here, we can then put a CH3 and a CH3 up above, like this. And then if we wanted to show the other isomer, we could go ahead and flip these two around, like this. And we can then see where we could put a CH3 up here. And where would the other CH3 go? Bottom right, exactly. It's going to go diagonal. So then from here you can put in the additional hydrogens. And so this here is a way that you can show the difference between cis and trans. And now if you want to name them, we first look at that parent chain, which the parent chain here has how many carbon atoms? There's 4. So a 4-carbon chain would be called bute. The suffix on here is going to be ene. And that double bond is located in which slot?
2.
Slot number 2. So we call this 2-butene. And likewise, the one over here is a 4-carbon chain. And we would call this one butene. And we count slots. We come up with 1, 2. It's going to be a 2-butene. But now to distinguish between cis and trans, we add on the prefix. This one here we call cis. This one here we call trans. And so cis is when they are on the same side of the double bond. Trans is when they are on opposite sides of the double bond. And you can kind of think of it like transatlantic. Transatlantic means you're going across the Atlantic. And so this one here has them the furthest apart. This one here, you can kind of think of them as being on the same side, like sisters. Not always. I know that I've seen sisters before, but okay. So, any questions? Okay. Now, again, the one that you're not responsible for in here is the 2-methylpropene. This is one that you are not responsible for down below here. You're not responsible for that one. So now, let's go ahead and look at your second page of the handout, which looks like this. We want to assign some names to these and draw some structures. So let's see. I will help you with the first one and, is that right? First one, which ones do I want to do here? Let's do numbers 2 and 3. Let's do 2 and 3. No, I don't, because I want to switch these up. Let's just do the first 2. That sounds good. All right, so now, let's go ahead and write some names for these. To do these, we need to identify and name the parent chain. So this is easy. We count across. How many carbon atoms are there? 5. So the prefix that stands for 5 is pent. What will the suffix be here?
Yne.
And it's YNE because it's a triple bond. What else do we need in this name?
We need the slot number.
Slot number, which would be the number 2. We count in the direction, gives us the lowest slot number. This is 1, 2. We count it in reverse. This would be 1, 2, 3. So it looks like we're going from left to right. And it's slot number 2. This would be 2-pentyne. Any questions on this one? Okay, then the last one. This one has a suffix. Now we're coming up with the structure. It has a suffix of ENE. What does this suffix mean?
Double bond.
Double bond. So we always start, especially when we want to show the difference between cis and trans. We start with this kind of backbone right here. How many carbons are going to be in this alkene?
8.
There's going to be 8. And this double bond is going to be located in slot number
4.
4. So if this is in slot number 4, we want to show trans. What would be the proper position for carbon atoms in here? If this one is right here, where is another carbon going to go? On the bottom right. So we put it on the bottom right. This shows trans. Of course, right now we're showing this in slot number 2. So how many more carbons do we need to put on here? Probably 2 more. So we have slot 1, 2, 3, 4. There we go. And we now have how many carbons? That's 6. There we go, 7, 8. So we can then put on your hydrogens like this. And we start adding in some more hydrogens. We'd have a CH3, CH2, CH2. This would be a CH2, CH2, and CH3 down here at the end. Always a good check when you write out a structure like this is to count the number of carbons and hydrogens. How many carbons are there in here?
8.
There's 8. Because it is an alkyne, an alkene. Number of hydrogens in this should be
16.
16, because an alkene has twice the number of hydrogens as it has carbons. We then start adding them together. We have 3, this makes 5, 7. There's 8, 9. This makes 11, 13. That makes 16 altogether. And this is the correct structure. All right, go ahead and do the next 2. Go ahead and do the next 2. Looks like the first one you're going to write out a structure. Second one, you're given a structure, you will write out the name. Okay, let's get marble clicking done. I'll give you some more time at the end of the hour. Marble clicking is distracting. I promise I'll give you more time. Let's stop the marble clicking for the moment, please. All right, last one here. Oh, first of all, take a look at the 1-hexyne. What is another way I could have written it on the left-hand side? Instead of CH, I could have written it as HC. Either one of them is a way that you'll find them written in your textbook and is a correct way. Then on the last one, I'm missing one piece to this name. What goes in here?
Cis.
Oh, cis.
Cis goes in here, exactly. So this would be cis3 heptene. It's an ENE suffix because this is a carbon-to-carbon
Double bond.
double bond. Any questions on either of these two? All right, then, here's where we're going to wrap up today. We're going to wrap up by looking at oxygen-containing organic compounds. And oxygen-containing organic compounds are very well summarized. I have a note here on page 666 in your text. Page 666 in your text.
Oh, God.
And when we look at them, here's what they will look like. And I'm going to summarize it up here anyhow. We have what are called alcohols. And if it is an alcohol, alcohols have a general formula that we write as ROH. Then we have a category of compounds that we call aldehydes. Aldehydes have a general formula of R, C double bond O, H. And there's a reason why I'm color coding them, which we'll see in just a bit. Then we have another key classification of compounds called ketones. Ketones have a general formula of R, C double bond O, R. We have what are called carboxylic acids. Carboxylic acids. And a carboxylic acid has a general formula of R, C double bond O, OH. Then we have what are called ethers, not ethers, but ethers. Ethers have a general formula of R, O, R. And then the last of these is a classification of compounds that we call esters. And esters have a general formula of R. Then we have a C double bond O, O, R out here on the end. Now at this point, you look at this stuff and you say, well, we need to define something, and what do we need to define? What is R? Exactly, what is R? Well, R is easy. R is just a general formula for an alkyl group. Okay, so if wherever you see an R is basically an alkyl group. Remember that an alkyl group is basically an alkane that has had one hydrogen removed. So every time you see R on here, R stands for an alkyl group. Now the other thing we're looking at is a number of different things, so what we call functional groups. Functional groups. And a functional group is a feature or a portion of a molecule. A functional group is a feature or a portion of a molecule that makes molecules that share these features function similarly as a group. And you're not going to be able to write all that down. It's better to look at these by example. But again, a functional group is a piece or a portion of a molecule that when molecules share these features, they make them function similarly as a group. So again, don't write it down, just know how it's used. And so one example of a functional group would be this one right here. In fact, you see this showing up a couple different places down below here. You see it show up right here, you see an OH in here. And we call this a hydroxyl group. It's called a hydroxyl group. And hydroxyl groups are found in alcohols. So basically, if we take an alkyl group and attach it to a hydroxyl group, an alkyl group attached to a hydroxyl group will give you an alcohol. And another common feature that you see showing up in here is this carbon double bonded to an oxygen. And this carbon double bonded to an oxygen is called a carbonyl group. Now, I did not invent these pronunciations. I don't know why this is called like a short I sound like hydroxyl, and this is like a carbonyl, like a long E. So hydroxyl group and carbonyl group. If you call this a carbonyl group, I'm not going to lose sleep over it. Okay? But again, a hydroxyl group and a carbonyl group are these two here. And then, if we combine the two together, that is, if we combine a carboxyl group and a hydroxyl group, a carbonyl group and a hydroxyl group together, notice we put this one together with this one, we get this feature right here, and we wind up combining the names, and we call this one here a carboxyl group. And that's why we call these carboxylic acids, because the carboxylic acids have in them this carboxyl group. And I should actually show this making a bond right here, because remember, carbons can make 4 bonds. So that's what this is implying here, is that this bond can bond then to an alkyl group. So if an alkyl group is attached to a carboxyl group, that makes it a carboxylic acid. So now, what we have up here is a number of different molecules. And I'd like for you to look very carefully at these molecules and determine what category they belong to. So look at those general formulas. I'm going to zoom out here just a bit so you can see all of them on the screen. Let's see here. I don't think that's quite all of them yet, but I think that will show all of them. There we go. So now let's look very carefully at these molecules and see if we can tell which classification they belong to. Now, your success in organic chemistry is going to depend on 2 things. The first thing you said is your ability to count carbon atoms. Your second key to success in here is being able to identify functional groups. So, what does this belong to? Whoa, try to hold it like this. What is this one? Yes?
Is it carboxyl group?
That's a carboxyl group, and that makes this a carboxylic acid, yes.
What's the difference between carboxylic acid and carboxyl groups?
Okay, the carboxyl group is just this piece right here.
Okay.
When it's part of a molecule, then that makes it a carboxylic acid. So the group itself is called a carboxyl group. When it's a part of a molecule, again, we call it a carboxylic acid. Good question. Okay, so this is a carboxylic acid. So your key to success again is going to be able to look at these molecules and tell what they are. Now look carefully at this molecule. What is this? This is an alcohol. This alcohol has how many carbons in it? 2. And I forgot to ask you on this one. This acid has how many carbons in it? 3. So we'd say that this is a 3-carbon carboxylic acid. Of course, if it has 3 carbons in it, what should we expect to see in its name? Prop. This is a 2-carbon alcohol. What should we expect to see in its name? F. Now, what alcohol do you think this is?
Ethanol.
This is ethanol. Exactly, this is ethanol. So you want to know what ethanol is? Where do we find ethanol?
Beers.
Beer, wine. Where else do you find it? It's what they add to your gasoline here in Minnesota. Okay? Let's look at this one. Carefully now. What is it? Not an ether. Because if it's an ether, you have to look at this oxygen. It's going to have attached to 2 carbons on either side of this oxygen. This one is also an alcohol. It's also an alcohol because what makes an alcohol is an OH. Okay? Now, how many carbons are in this alcohol?
4.
There's 4. So what should we expect to see in its name?
I meant bute.
Bute. So this is going to be called a butanol. There's a little bit more to this name than that, but this is going to be called butanol. How about this one here? This one's a ketone. You identify this as a ketone because you see a carbon double bonded to oxygen. This is called a carbonyl group. And then on this side, you see an alkyl group. On this side, you see an alkyl group. Okay, so that makes this a ketone. This makes a ketone. Now, how many carbon atoms are in this ketone? 5. So what should we expect to see in its name? Pent, right. And so the name of this one is actually going to be a pentanone. Pentanone is going to be its name. And hopefully you can begin to see some patterns. In a ketone, notice that the name ketone ends with -one. The name of this is going to be called pentanone. So ketones end with an O-N-E suffix. This here was an alcohol, and alcohols end with a suffix of O-L. So this is ethanol. This one here is butanol. And this one here was a carboxylic acid. This one's going to end with a suffix of OIC acid. And then if we go down to the last one, look carefully now at this one. What would this be classified as?
Aldehyde.
This is an aldehyde. Aldehyde because we have a, right, we have a carbon double bonded to an oxygen and then a hydrogen out on the end. This makes us an aldehyde. There's how many carbons in here?
4.
4. So it's a 4-carbon aldehyde. And so if there's 4 carbons in there, we'd expect to see what in its name? Bute. Okay, so that's going to be part of your success in dealing with these. Now, if you were to write them out, here's how we'd write these out respectively when we write out their structures. We'd write the first one, and I'm going to zoom back in here a bit. Okay, we'd write the first one as a CH3, CH2, C double bond O, OH. In fact, I'll color code these for you to make it a little easier to see them. C double bond O, OH. Then the next one was the ethanol. If we write this one, we'd write it as CH3, CH2, and then we put on an OH here at the end. If we do the next one, we want to recognize this one, we put in a CH3. Let's say we look at it like this, because I want to work with this tomorrow. CH3, CH2, then we have a CH and a CH3 on the end. Then sitting up above here we have an OH. And then if we do this next one, write out its structure, would have a CH3, CH2, CH2. Then we'll put this carbon double bonded to an oxygen in here, and the CH3. And then on our last one, we wanted to show the 4 carbons. We put in CH3, CH2, CH2. Then we have our carbon double bonded to an oxygen, and then the hydrogen. Well, we got about a minute and a half left here. We're not going to name these today, but I want to direct you to where we will be starting here on Thursday. If you go to your handout now, let's see, we got this page right here. It's the very back page of that first handout. This here now is the nomenclature of alcohols, aldehydes, ketones, and carboxylic acids. So we are going to start then on Thursday by naming these. Notice now that all of these here follow the same convention. And that is, we basically are going to name the alkane that has the same number of carbon atoms. Then we're going to drop the letter E from the alkane name. Depending upon whether it's an alcohol, aldehyde, ketone, or carboxylic acid, we then add different suffixes onto their names. Now this worksheet, this is not anything that I'm going to wind up collecting in here. This is something that I have posted to D2L. And in D2L for this date, or maybe it was for last Thursday or this coming Thursday, you'll also find the answer key to this worksheet as well on that content section. Any questions? I would anticipate you don't know how to do this today yet. We will finish this up on Thursday. All right, that's it.